Hi, I'm Bailey with my math experts, and today I'm going to show you how to simplify the following quotient: 8x to the 6th z to the 4th plus 4x to the 4th z squared all over 4x squared z. So something that I see a lot with students when they encounter problems like this is that they just start going crazy simplifying everything that they see. So they just start going like, oh, this is an x to the 6th, this is an x squared. That means this is going to go away, this is going to go turn into a 4. I see there's a 4 here and a 4 here, those go away. I see there's a z here and a z here, that goes away, and it'll look like this. And unfortunately, the final answer you get from doing something like this is not one of the answer choices, meaning this is not the right way to approach something like this. So I'm going to show you a method that will work 100% of the time when you encounter something like this. It does take a little longer, but it ensures that you're going to simplify things that can be simplified and you're not getting rid of things that don't work. So the first thing to keep in mind is that whenever you have two things that are being added or subtracted together in a fraction, you should really treat those like it's in parentheses. So this is the quantity of two things being added together. And then the next step here, what we're going to do is we're going to factor out, using greatest common factor, anything that we can factor out of both of those terms. So it looks like 8 and 4, we can factor a 4 out. In terms of the x's, we have x to the 6th and x to the 4th. So the biggest x that we can factor out is an x to the 4th. And then in terms of z, we have a z to the 4th and a z squared. We can factor out a z squared. And then factoring out is just division. It's undistributing is another way to think about it. So in order to figure out what's left inside these parentheses, we would just need to divide each term by what we factored out. So 8 divided by 4 is 2. X to the 6th divided by x to the 4th is x squared. Reminder that for exponent rules, division is subtraction. So if you have the same base, the powers subtract. So 6 minus 4 is 2. And then z to the 4th divided by z squared. 4 minus 2 is 2. That's going to be a z squared. And then for our second term here, 4 divided by 4 is 1. X to the 4th divided by x to the 4th is 1. Z squared divided by z squared is 1. At the end of the day, all that's left over there is 1. And then we have our denominator. We haven't done anything with that yet. And now you can start canceling. Now that we have two things that are being multiplied together, we have this term being multiplied by this quantity. Now we can start canceling. So when things are being added together, you can't start canceling. It has to be things that are multiplied together in order to start canceling. So let's see what cancels here. We have this 4 is going to cancel. This x squared is going to simplify this to an x squared. And this singular z is going to simplify this to a singular z. So let's rewrite that. We just currently have x squared z to the first times our stuff in parentheses. And we no longer have a denominator because everything canceled in our denominator. And then now, in order to get our answer looking like one of the answer choices, we're just going to need to distribute this stuff back in. So we're going to have our 2 x squared times x squared is x to the 4th. Again, a exponent rule here. Whenever you're multiplying exponents with the same base, you're adding the exponents. So 2 plus 2 is 4. And then z times z squared is going to be z to the 3rd because 1 plus 2 is 3. And then this plus 1, that's just going to be exactly the same thing. And then this is going to be our final answer. We can compare this to our answer choices up here, and it looks like that is A. So we have successfully reached one of the answer choices. Great. Thanks for being here. Hope that helped.